Today, we present the new Electric Actuation Sizing Tool. Let's explore how it works together. First of all, make sure you are on the website shop.komatsu.com. In the menu at the top left, you will find the tools list. By clicking on it, you can select the Electric Actuation Sizing Tool. After accepting the disclaimer displayed upon entering the tool, proceed by selecting the type of application to size. Let's choose the positioning option with an electric cylinder. The first step is to select the orientation of the cylinder, specifying the rotation angle. This angle can range from -90 degrees to +90 degrees, where the rod points upward. If set to 0, the actuator will be horizontal. In this case, we assume a vertical application. The second step involves selecting the friction coefficient between the load and the surface on which it slides. Clicking on the editable field will display a table with suggested values based on the type of guide system intended for the application. For this example, let's assume a ball bearing guide and set the value to 0.04. Once these two parameters are defined, click the Next button to proceed. In this phase, you need to input the operating cycle data for the application, including target positions, corresponding movement times, as well as the loads and forces involved. The first parameter to define is the starting position, which is the position of the rod before the cycle begins. For each step of the working cycle, several parameters need to be defined. Target position, which specifies the absolute position the actuator must reach to complete this phase. Let's assume we need to move to 100 millimeters. Mass to move in this case, we set the mass to 20 kilograms. External force acting on the rod. This force can be either push or pull and is added to the mass already present. It's essential to define the direction of this force. A push force means the cylinder must counteract a force that resists the rod's outward motion, effectively pushing the rod back into the cylinder. A pull force, on the other hand, means the cylinder is counteracting a force resisting the rod's inward motion, effectively pulling the rod outward. This rule applies regardless of the cylinder's motion. Let's assume an external push force of 150 newtons. Once these parameters are defined, you can select the input motion, which is the law of motion determining how the cylinder executes this phase. There are 4 possible motion profiles. The first two options, 1/2 and 1/3, only require the time to reach the target position, while the other two also require speed or acceleration values. Once the first step is defined, you can proceed to the second phase by clicking the Add Movement button. By default, the tool generates a new row with the same payload and target position as the previous step. If you set the target position to match the previous step, the cylinder will not perform any movement. Instead, this step will become a pause phase, indicated as rest time under the input motion parameter. In this case, the travel time is interpreted as the pause duration, during which the actuator might still need to maintain position against an optional external force. Using the same principles, define the third step as the rod retraction phase, setting the target position to 0 millimeters, a new opposing force of 200 newtons, pull, and speed time as the input motion. The speed value must fall within the speed, min and speed max limits. Let's set a speed of 0.3 meters per second, which falls between the limits of 0.203 meters per second and 0.4 meters per second. In this example, we used 3 steps, but the tool allows adding more steps as needed. To view the result of this calculation, click the Open Results button. On the results page, in the table at the top, we see a complete list of possible solutions capable of executing the desired cycle. Each row represents a different solution, starting with the option that has the shortest duration, typically corresponding to the smallest cylinder size suitable for the application. By selecting a solution, the details of its components will appear in the overview window at the bottom of the screen. The first page displays the first 10 solutions. Additional solutions can be viewed by clicking Load More Results. Some details, such as the rod thread or motor characteristics, for example, with or without a brake, do not define a separate solution but remain editable within the overview window of the selected option. The best way to choose the desired solution is by using the filters on the left-hand side of the screen. Let's select the Series 6E. Choose the cylinder size, for example, 32. The type of communication protocol. As you apply filters, the number of available solutions, sorted by duration from shortest to longest, is reduced. You can also filter by specifying the minimum lifespan in kilometers that the actuator must guarantee. Once the solution to evaluate is selected, you can modify the editable parameters, such as the cable length. After defining all parameters in the Overview tab, you can proceed to the Accessories tab. By default, a sensor suitable for the selected cylinder will appear, and you can add other mounting accessories. In this case, let's assume we add an anti-rotation guide from the 45 NHB series. Switching to the Bill of Material tab, you will see the complete list of all components selected earlier. By clicking the Request a Quote button, an email will be sent to the dedicated office, which will provide a quotation to the requester's email address. In the final tab, Report, you can view and save the technical report of the calculation performed using this tool. The report contains and organizes all the information entered previously, including the obtained results, from the input data to the overview and the final bill of material. The report can be saved and used as a summary document, which can also be sent to the Komatsu team for the quotation phase.